Hello friends, welcome to Learner's Planet. Friends, this is our first session for probability. In this session, we are going to discuss various terminologies, definitions related to probability, and I would suggest you to attend all the sessions of permutation and combination before you proceed for the sessions of probability, because it's really necessary to understand the concepts of permutation and combination, right? So let's begin with the session. Now the first thing is random experiment. Now what's random experiment? All the outcomes of the experiment are known in the advance, and the exact outcome of any specific performance of the experiment is unpredictable, not known in advance, right? Now what exactly this term mean? See, suppose you are throwing a dice, right? Now what number will appear you cannot predict, right? That means it is a random experiment, right? But you know that there are six possibilities. Either number one will appear, two dots will appear, three dots will appear, four dots, five dots, or six dots will appear, right? So you know all the outcomes, but which outcome will appear, that you don't know, or you don't have any control over there. So that's called random experiment, right? Precisely, the outcome of the event is not predictable. Suppose you have a deck of 52 cards. You are drawing one card and you don't know which card will come, right? Maybe it's an S, maybe it's a king, it's a maybe diamond, maybe any other card, right? So you don't have any control or you cannot predict, right? So that's what is a random experiment. Next thing is a sample space. Now, what's a sample space? That is the total number of possible outcomes, right? Suppose you throw a dice, right? If you throw a dice, there are six possibilities of outcomes. That is either one dot will appear, two dot will appear, three dot will appear, four dot will appear, five dot, or six dots. So that's the sample space, right? So if I have to write the sample space of a dice, so I just can write 1, 2, 3, 4, 5, 6, right? Now what's probability exactly? Probability, that means possibility of occurrence of an event, right? Suppose we are throwing a dice and the possibility of outcomes is 6, like that 1, 2, 3, 4, 5, and 6. Now I have to find out the possibility of maybe an even number. Okay, so if we throw a dice, so what are the chances of getting an even number, right? So in all we are having six choices, right? So out of six choices we are having three choices for even number, right? So this is what 3 by 6. So we can say it's 1 by 2. The probability is 1 by 2, or there are 50% chances of getting an even number, right? 50% chances of even number, right? So what's the probability exactly? Probability is all possible outcomes, and here it's favorable outcomes, or we can say events. So probability is favorable events by all possible events. So in this case all possible events are 6, and the favorable events, suppose if we talk about even numbers, there are 3 even numbers, 2, 4, or 6. So favorable events are 3. So the probability of getting an even number by throwing a dice is half, right? Similarly, we can take one more example. Suppose we have a deck of 52 cards, and we have to find out the probability of getting maybe a card of hearts, right? So in all, for a single card, the total possible events are 52, right? For a single card I'm talking over here. Now out of this 52, how many cards are of hearts? So in all there are 13 cards of each suit. That is 13 hearts, 13 clubs, 13 spades, and 13 diamonds, right? So if we talk about the card of hearts, so total possibilities are 52 for a single card, and out of 52, 13 cards are there of hearts. Okay, so probability of getting a heart out of 52 cards will be 13 by 52, or we can say 1 by 4, or in other words we can say that if we draw a card from a deck of 52 cards, 25% chances are there that we will get a card of heart. That's 25%, right? So probability is the ratio of favorable events by and is to possible all possible events, right? So the maximum value of probability is 1. That is the maximum value, right? That means the chances of occurrence of any event cannot be more than 100%, right? So at max, what would happen? An event would occur, right? So maximum chances are 100%. Okay, so the maximum value of the probability is 1. So we can say probability value of the probability is always less than equal to 1, right? So this is the basic about probability, right? Now there are various types of events, and first of all, let's discuss about the mutually exclusive events. Now, what are mutually exclusive events? See, there are two events. Suppose there are two events, and the condition is that if first event occurs, then the second cannot occur, or the second event occurs, then first cannot occur. Right? So these two events are mutually exclusive events. Right? Suppose we take an example of our daily life. Maybe we have to choose a president of a college, suppose, right? So two persons are there, A and B, right? And there is just one seat for the post of the president, right? So either A can be selected or B can be selected, right? So selection of A and B is mutually exclusive event. Either A will be selected or B will be selected, right? So we have to or we can say, if I have to calculate the probability of A and B, how would I do that? Probability of selection of A is known as PA, and that is, what are the total number of seats? 2, right? And if A has to win, the chances are 50%, right? Or the probability of winning of A is half. Similarly, probability of winning of B is also half, unless until some specified conditions are there, right? So probability of winning A is half, and probability of winning of B is half, and probability of A and probability of B, right? That is PA plus PB is A union B. This is a relationship. Okay, and here A and B, that means winning of A and winning of B are mutually exclusive events, because if A will win, B cannot win, and if B will win, A cannot win, right? The next is, if A is any event, then PA bar is 1 minus PA. That means if probability of occurrence of any event is PA, then the probability of uh, like negation, that is, if that event should not occur, is 1 minus probability of occurrence, right? So probability of PA bar is equal to 1 minus PA, or we can say probability of occurrence of event A plus probability of not occurrence of event A is equal to 1, right? So in all, the total value of the probability will remain same, that's 1. Okay. Friends, the next is mutually non-exclusive events, right? Now what's the meaning of that, mutually non-exclusive events? I just take an example over here. We try to calculate the probability of a red or 4 from a deck of 52 cards, right? So if we have to precisely we have to draw a card that should be either red or it should be a 4, right? Either red or 4. Okay, a single card we have to draw. Now there are two events, that is suppose PR and the other is P4, right? So we have to draw a red card or we have to draw a 4, right? Now, are they mutually exclusive? What was mutually exclusive event? Mutually exclusive event is that if this event is happening, this cannot happen, and if this is happening, this cannot happen, right? So this was mutually exclusive event. But in this case, it's not like that, right? So how it's possible? See, drawing a red card and drawing a 4, both the events are not mutually exclusive because we have two cards available with us in the deck of 52 cards which are red as well as 4, isn't it? The card of heart and the card of diamond. So we have 4 of heart also and we have 4 of diamond also. So that will be calculated in this also and in this also. So while we are calculating the red card, we will be considering heart and diamond both as well being a red card, and while we are calculating cards of 4, we will be calculating 4 of heart and 4 of diamond, right? So 4 of heart and 4 of diamond being red as well as 4 is coming in the calculation for 2 times, under red also and under 4 also, right? So the probability is getting disturbed over here, right? So what we have to do, we need to eliminate these events at least for 1 times, right? Because we are calculating them for 2 times. So if we deduct them for 1 time, so they will be calculated just for once. So in the case of mutually non-exclusive events, we use this relationship. Now, how do we put the values in this relationship? Though it's not necessary to mug up the formula, it's just a simple concept that you will understand once we finish this problem. So first of all, let's calculate the draw a red card, right? So in all, there are 26 red cards out of 52 cards from a deck, right? Now let's calculate the force, probability of force. So there are 4 fours out of 52, right? So probability of a red card is this, probability of a 4 is this, so probability of a red or 4 will be this, right? So either this will happen or this will happen, right? Now, as I've already discussed that we have calculated heart 4 in both the cases. Heart being red is calculated in this and 4 being 4 is calculated in this, right? So this heart 4 and diamond 4, both of them are calculated twice. So we will deduct them, right? So once we deduct, we'll be getting so we have added the 2 in this, we have added the 2 in this, so we have deducted the 2 once, so the remaining will give us the probability of a red or 4. Okay, so what is the total answer? 26 plus 4 is 30, 30 minus 2 is 28 by 52, right? So that's the total probability or answer to the problem. So here I have taken the example of a mutually non-exclusive event. Similarly, I can take one more example for mutually non-exclusive event. If I throw a dice, just a moment. Now the question is, suppose I throw a dice and I have to find out the probability of an even or prime number, right? That means the number which is appearing on the dice should be either even or it should be a prime, right? So these two are even number and prime number are two different events, right? So let's calculate the probability of getting an even number. So even number are, I just write the sample space, it's 2, 4, 6, and the sample space for prime number is suppose S2. So it will be, the total sample space will be 1, 2, 3, 4, 5, 6. So the favorable outcomes in the case of even number are 2, 4, 6, and for the prime number it is 2, 3 and 5. right? So probability of getting an even number will be what? These three elements are there out of 6, so it's 3 by 6. Then or, we'll put a plus. Prime number is 1, 2, 3. Further 3 by 6, right? Now just observe the two sets carefully. We have a number that's available in both the sets. So we have calculated 2 in this case also. We have calculated 2 in this case also. So we should deduct it for 1. So we'll be getting the actual probability. So it's 5 by 6, right? Because it's not correct to add 2 or take 2 for 2 times. Okay. So what was 2 actually? 2 was actually an even prime number. That means 2 is considered as a 2 is actually an even number and it is also a prime number. So it's coming under both the events, right? So probability in the case of non-exclusive events, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B, right? That means the probability of both the events happening simultaneously is probability of A intersection B that we need to deduct from both the probabilities. Okay, now I'm sure you are clear. Now let's take independent events. Before we take independent events, I would like to discuss if there are three events which are non-mutually exclusive, then which relationship will be used, that I would like to discuss over here. Now, to explain this, I would just like to take an example over here. I have to find out the probability of maybe I just wish to draw a card from 52 cards, and the card should be either red or heart or maybe a 10. Okay, or I just say maybe a king, right? So these are the three events. The card should be either red or heart or a king, right? So I have to find out the probability of this event, right? So there are three events. So I just find out the probability of getting a red card. How many red cards are there in all? There are 26 red cards, that is 13 of clubs, 13 of hearts and 13 of diamonds. So it's 26 by 52, right? Then plus how many hearts are there? In all there are 13 hearts out of 52. Now how many kings are there? There are 4 kings out of 52. So this is the probability, right? Now what's happening over here? Red and heart. Okay, see, all the hearts are red, right? So we have already calculated hearts in this, and further separately we have calculated over here, right? So if all the hearts are red, so we cannot calculate the heart for 2 times, so we need to deduct. Now what is that? That is actually A intersection B, right? Or B intersection C, whatever you say. So it's A intersection B. That means the combination of red and heart, that is 13 cards we need to deduct, right? Now next is heart and king, right? So we need to deduct heart, king of heart, because while we calculated heart, we already calculated king, because king, red king or maybe heart of king of heart is also part of heart. So we need to deduct that also. So that's actually B intersection C, right? Similarly, we need to deduct red kings. How many red kings are there? King of diamond and king of heart. Both of them are already calculated in this being red cards. So we need to deduct these 2 cards, right? So till here we deducted the combination of red and heart and king, and red and king. So we deducted all the combinations. Now this is the calculation left with us, right? But there is further a twist over here. When we were deducting this and this, we forgot one thing, that we are available with a card that has been deducted from all the possibilities, that is red, heart king. That means the king of heart, that has been deducted, right? Because being red card, being heart, and being king, it has been deducted from all the three. So we need to add them once, right? So this is the probability of getting a red card. This is probability of getting a heart. This is probability of getting king. We deducted the probability of red and heart. We deducted the probability of heart and king. We deducted the probability of red and king. While we were making all the deductions, we deducted the king of heart, which was red. So we need to add them once, right? So this is precisely the entire calculation. Just make it over here. So it's 13, it's 13, then this one, so it's 26 plus 4, 30, 30 minus 2, it's 28, right? So this is whole the concept of three new non-mutually exclusive events. I hope you are clear. Now next is independent events. Now what are independent events? We say two events A and B independent if the occurrence or non-occurrence of the first event doesn't affect the probability of occurrence or non-occurrence of the other event, right? So suppose the probability of occurrence of the first event is PA and the probability of occurrence of the second event is PB, then probability of occurrence of both the events, that is probability of A intersection B, will be product of their individual probabilities, right? Similarly, if we have three events, something like this, so the probability of occurrence of all the events will be PA into PB into PC. I just explain you this thing with one example. Suppose in a class, maybe we are having 5 boys and maybe 3 girls, right? And I have to choose a boy representative as well as a girl representative. That means I have to choose one boy and one girl. One boy and one girl. Now just see this end, right? That means this event is happening and this event is happening. This event is happening, this event is happening. That means if we select boy, that doesn't make any impact on selection of girl. If we select any girl, that doesn't make any impact on selection of boys. So the selection of boys and selection of girls, both the events are independent, right? So we have to select one boy and one girl. So the probability of this event, one boy and one girl, is suppose B intersection G, that is one boy and one girl, is probability of B into probability of G. Now what's the probability of B? In all, we have to choose the two persons, that is 5 plus 3, 8. So that's 8C2. Out of 8, we have to choose two persons, and one should be boy, that is 5C1, and other should be girl, that is 3C1, right? So it's 5 into 3 by 8 into 7 into 2, right? So that's 15 by 28, right? So I just make a quick recap over here. From the 8 students, there are 5 boys, 3 girls. I have to choose 2 students. One should be boy and other should be girl, right? So from 8 students, I have to choose 2 students. So these are the total number of events, and out of 5 boys, 1 boy should be selected, and out of 3 girls, 1 girl should be selected, right? So we simplified that. 5 into 3 by 8 into 7 by 2. Just simplify this and we get the probability as 15 by 28, right? So I hope you are clear with the term independent event. We'll be taking examples at the time, it will be more clear to you, right? Now friends, let's take some simple examples so we can understand the concept of probability. Suppose I just toss a coin. Now what's the probability of getting a tail, right? So what's the sample space if we are just tossing a coin, that is 2, either head or tail, right? So there are two possibilities or two outcomes, right? And what's the favorable outcome? That is, we want a tail. That means the favorable events are 1. So the probability of getting a tail if we toss a coin is half, right? Similarly, if we wish to find out the probability of getting one head, so it will be also 1 by 2, right? Now let's change it to a certain extent. Suppose we are throwing two coins, right? Coin 1 and coin 2, right? And we have various events. Let's discuss them one by one, right? So what will be the total sample space? uh, Suppose we are getting heads on both the coins, tails on both the coins, head, tail, and tail, head, right? So in all there are four possibilities, right? And let's discuss the probability of various events in this case. Suppose the first question is, what is the probability that if I toss two coins, I'll be getting tails in like both the times or both the coins, right? If I'm tossing two coins, what is the probability that I get tail on both the coins, right? So in all there are four events. And how many favorable events are there? If I have to get tails on both the coins, so I'll be just having a single event. So the probability of getting tails on both the coins is 1 by 4, right? Similarly, if I wish to calculate heads on both the coins, so that will also be 1 by 4, right? Now if I have to calculate the probability of head on the first coin and tail on the second coin, then it will be also 1 by 4. And if I have to calculate tail on the first coin and head on the second coin, that is also 1 by 4, right? So we discussed these four events. Now the what is the other question is, suppose what is the probability to get a tail on the second coin? First, on the first coin whatever may appear, but what is the probability of getting a tail on the second coin, right? So at the second place we have this event as well as this event. So we have two events out of the four events in which we are getting tail on the second coin. So it's 2 by 4. Right? So similarly, various other questions can be framed. Okay. Now suppose instead of two coins, we are having three coins. Then further, there will be a sample space. And how do we calculate the sample space? It is the product of total possible outcomes of individual event, right? In the coin 1 there are two possibilities, in the coin 2 there are two possibilities, so 2 into 2 4, right? So if we have three coins, suppose 1 2 and 3, right? It is having two possibilities, head and tail. It is having two possibilities, head and tail, and in this case also. So the total sample space will be 2 into 2 into 2. So it's 2 into 2 into 2, that's 8. That means in this set, or the total possible outcomes will be 8. Right? Now I just write over here all the possible outcomes. So I just write over here 8 possible outcomes. So it's head, 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 tail, 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 head, head, tail, tail, head, head, tail, tail, then head, tail, head, tail, head, tail, head, tail, right? So similarly, if you have like 16 possibilities, that means 4 coins, then similarly you can proceed for the fourth coin. You would take 8 times H and 8 times T. So now let's discuss the various cases. Suppose the first one is I throw the I toss the 3 coins. What is the probability that I'll be getting 3 heads? So that's head, head, head. That's 1 out of 8. So it's 1 by 8. Similarly, if we have to find out the probability of 3 tails, so that will also be 1 by 8. Now suppose we have to find out the probability of 2 head and 1 tail, right? So let's see the various events: 2 head, 1 tail, 2 head 1 tail, 2 head 1 tail. So we have 3 events over here, right? So it's 3 by 8. Okay. So this way various questions can be framed, and the procedure is really simple. Okay, so friends, we'll be taking more problems and concepts in the next session. This was just the basic introductory sessions of probability. In the next session we'll be taking problems, simple problems. So do revise this session, and do not forget to revise all the concepts of permutation and combination. It's really necessary for probability. Okay, so bye bye.